So what we're going to start doing is we're going to start formalizing and naming our tests. So this is called the Nth Term Test for Divergence. And essentially, this was our very first test at the beginning. And we're just saying that a to the n must tend towards 0. So I'm just going to put that in brackets here. A to the n is tending towards 0. Okay? And if it doesn't pass that test, we don't even need to check for the convergence of the series. Because if the sequence doesn't go to 0, then we can't even, there's no chance the series can. Okay, so this is called the Nth Term Test for Divergence. And really, this is our first criteria that we had to pass. So we can see that if we look at a series like this, n plus 1 over n, we can just establish right away it doesn't converge because this term does not go to 0. So for A, I could just show that the limit, okay, the limit as n goes to 0, n goes to infinity of n plus 1 over n that is equal to 1. That means that A infinity equals 1, therefore series cannot converge. So this is all this is. The nth term test for divergence is just testing the last term of the sequence. We can see here, this one here that doesn't exist. For B, it doesn't exist because it's just going to flip between -1 and 1. It's not tending towards 0. It doesn't have a limit. It cannot converge. The limit does not exist. Therefore, it must be divergent. For this one here, we can see that as we let the limit, and we can do the same thing here. We just do this a little bit more formally. Basically, now we're formalizing this, just saying the limit of -1 over n over 2n minus 8, okay, as it goes to infinity. This is tending towards -1/2. However, we can also say that since it's going between positive and negative, we can also say that it does not exist. Therefore, it's divergent. Okay, for D, we need to test this one. How does this, what's happening here? Does this even pass the Nth term test? Okay, so what can we do here? We can do the Nth term test here. So we can do the limit as n goes to infinity of, and we're going to write it like this, 1 over sine n over 1 over n. Now this is going to be 0 over 0. But we also know that, and we could apply L'Hopital's, but we also know that this is really sine 0 over 0. And we know that sine 0 over 0 really is equal to 1. And since this is an does not tend to infinity, or a infinity does not tend towards 0, okay, this means that the series is divergent. Okay, so this nth term test, and all we're doing now is just formalizing what we've kind of talked about before. It's called the nth term test for divergence. This is our very first criteria that we have to pass, where the Tn or the An must go to 0.